All right, today we're going to practice drawing electric field lines. Now, from our, I'm going to give you an answer to the homework that most of you guys didn't do last night. Okay, and the direction, the field lines, okay, are given by the vectors. The vectors of force. At that. Okay, it's the vectors of force upon a test charge at that point in space. So we're going to start with a basic one. All right, this has a, we have a charged particle here. And, what's that? Point. Point, yep, point in space. Okay, and if we move a positive test charge, let's say we put our positive test charge right there. Okay, if this is a positive and that's a positive, that means that this is going to experience a force away from the one in the center. Okay, so it'll experience a force in that direction. And if we put one down here, then it's going to experience a force that way. We put one over here, it's going to experience a force that way, because our test charges, remember, our test charges are always positive. Okay, so if we move it to positive test charge and here another positive charge, all of the forces it's going to experience are pushing away. Yeah? Okay. Now let's bring in a different one. Let's change our color here. And let's say that we bring our positive test charge near something that is negative. Okay. Well, if we bring our positive test charge here, then its force is going to be attractive. Like that. Okay. Now, these are just for single charges. If we just have one charge, it's pretty straightforward as to which direction that the force is that we're going to feel. Well, what if we have a system of more than one charge? Okay, so what if we get a positive charge and a positive charge? Okay. What is going to happen to a test charge that's right here? It's going to stay there. Now, mind you, I intentionally drew this. That was right in the middle this way, but not this way. Okay, both of these. In fact, let me do. This is going to experience a force coming from this guy. That would go in that direction. You can see that. And this one would experience a force from that. Going in that direction, right? Well, the left and right parts of this are going to cancel each other. This is going to be in the negative direction to the left, and it's going to be in positive direction to the right. Yeah? And so they'll actually cancel each other, but they both experience a force going up. So, yeah, Jack, what you were doing, it would end up going in that direction. Yeah, they both kind of squeeze it out and push down that direction. So how about one that would be over here? Where's this guy going to go? Well, this one's kind of pushing. This is pushing that way, and this one's pushing away, right? So this would wind up splitting the difference, which actually kind of go that way, right? Well, actually, no, I take it back. Hold on. But because it's closer to this one, this is actually going to go further this way. So it's going to be more like that. And so it'll curl. It would kind of curl this way. Okay. So what happened? So what we're going to start drawing is these field lines where it kind of indicates the path that a positive test charge would take as it's released in this field. So these would wind up, if okay, does this make sense? What happens here? That these, if we put something in here, it's not going to stay. There is a point right here where it would experience a net force of 0. Okay, but it would be highly unstable, and as soon as it was just a little teeny tiny part away from that one particular point, it'll shoot off in one direction or the other. Okay, but this would also experience the same. Okay, so now, if we were to put our test charge anywhere in this field, we'd be able to determine where it's going to travel when it's in the field. Okay, now my challenge to you guys is, what if I change one of these to a negative? Okay, what would the lines look like? Okay, well, if I change one of them to a negative, and we put a positive test charge, it's going to want to move away from the positive and towards the negative, right? So now we're going to have different kinds of lines. So that is pretty much what your homework is tonight, is to do pages 17 and 18 and draw field lines in various situations. Okay, based on, determine whether the particle is positive or negatively charged, and you'll draw some of the lines on your own on the back side. A couple rules, though. The density of the lines, so the closer the lines are together, means the stronger the magnetic field. Stronger the electric field. 1. 2, lines never cross. These, I know I drew some crossing here, but this is this diagram. The actual field lines that in a diagram, they never cross each other. Okay, because there's always some direction that a particle would travel, and you're never going to have two particles run into each other. All particles will behave the same, and because of that, they're never going to cross each other. So more lines equals stronger electric field, and lines never cross. And the last one I'm going to give you guys is always from positive to negative. Okay, that the lines, if you have two different charges, the lines will always go out of the positive charge and into a negative charge, because that's going to be the direction of the force on a positive test charge that you put in the field. Yeah. Okay, so that should be it. And there's no real math to do on this assignment. So that's all we really need for this.